Hey everyone, today we'll learn how to interface an ultrasonic sensor, that is HC-SR04, with an Arduino Uno and measure distance using sound waves. We'll explain the code step by step so even beginners can follow along easily. Components required: Arduino Uno, HC-SR04 ultrasonic sensor, jumper wires, breadboard is optional, and USB cable for connection to your PC. How to make the connections? Connect HC-SR04 to Arduino Uno like this. VCC of sensor is connected to 5 volt Arduino. Ground is connected to ground. Trigger pin is connected to pin number 9 and echo pin is connected to pin number 10. Code explanation. These lines defines two constants for pin connections. Trig pin is the pin that will send the trigger signal to the sensor. Echo pin is the pin that will receive the reflected signal, that is echo, from the sensor. Constant int means these pin numbers will not change during program execution. Void setup function, which runs once when the Arduino starts. It is used to initialize settings like pin modes and serial communication. Serial.begin 9600 initializes the serial communication at 9600 bits per second, that is baud rate. This allows the Arduino to send data to the serial monitor on your computer. So here trig pin is set as an output because it sends out a pulse. Echo pin is set as an input because it listens for the returning echo. This closes the setup function. Void loop, the loop function runs repeatedly, so the sensor keeps measuring distance continuously. Sets the trig pin low for 2 microseconds to ensure a clean signal before triggering, and a short delay to clear any noise on the line. So therefore we have given delay microseconds of 2. So these 3 lines, digital write, it sends a 10 microsecond high pulse to the trig pin. This tells the ultrasonic sensor to send out a sound wave. The wave travels out, hits an object and returns back to the sensor. A long duration, it means here pulse in listens on the echo pin. It measures the time in microseconds for which the echo pin stays high. This time corresponds to how long the sound took to go to the object and bounce back. So this particular line, float distance, converts the time into distance in centimeters. 0.034 centimeter per microsecond is the approximate speed of sound in air. We divide by 2 because the signal travels to the object and back. Serial.print line prints the calculated distance to the serial monitor in a readable format. So delay of 500 means it waits for 500 milliseconds before taking the next reading. So this helps avoid spamming the serial monitor with too much data. So this ends the loop function, which will automatically restart again. This is the output we are getting. Now the obstacle is around 10 centimeter apart from the ultrasonic sensor. If we move away from ultrasonic sensor, we can see the distance is increased now to 20. If we move near to the ultrasonic sensor, then the distance is reduced.